Hey everyone, welcome to another video. So today we're going to start moving on from division to considering dividing some bigger numbers now. So we're talking about in this video some mental strategies for division. Now this is specifically for when we can't use a calculator, which in year 7 where this topic is taught, in Australia where I'm from, we can't use calculators. So we have to come up with these strategies like we've been doing with all of the other operations so far. And we want to do this for division. So I've got a question here. And this is, we want to divide 52 by 4. And in doing this, I want to see if you guys can pick up on, and I'll talk about it later, a rule that we noticed in some previous topics that we can possibly apply as a mental strategy for dividing numbers. So here I have 52 divided by 4. Once again, I have my dividend, I have my divisor, and I've shown my 52 with these circles here. Now, this is not a this goes past the times tables for 4 that we've done so far. So we need another strategy as these numbers get bigger to think about possibly coming up with ways to divide these. So since I don't know what 52 divided by 4 is, I just can't tell so far, why don't I split this group up here into some smaller bite-sized pieces that we may be able to work with. So instead of doing my entire 52 here, why don't I just split this up, shift these down a little bit, and work through down here. So how many of these do I have here? Well, I have 40 now. I've got a column of 4 by 10. So if I were to count all of these together, I would get 40. So I've split my 52 up into 40. And if I count these 2, 4, 6, 8, 10, I have 12 down the bottom here. So my 52, I've just split up into 40 plus 12. And I've split this up into smaller numbers because if I know my times tables, I should know how many times 4 goes into 40 as well as 12. So now that I have these things here, I can think about dividing these separately. So what I'm doing here on this first one, I'm looking at 40 divided by 4. So if I split up my 40 here into 4 equal bits, how many do I have in each one? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I divide 40 by 4, I get 10. And that should be familiar from your times tables because multiplying and dividing are opposite operations. So if I multiply 4 by 10 to give me 40, which I know from my times tables, I can divide 40 by 4 and that will give me 10. So we can go back and forth with these types of operations. So if we now split my 12 I divide 12 by 4, well, I want to see how many equal groups I have. And here I haven't really drawn it too nicely, but if I divide 12 by 3, 12 by 4, I'm going to split this up into 4 even groups. So I have one here, one here, one here. And if I move this last one down with these guys, I have 4 even groups of 3. So this becomes 12 divided by 4. And once again, if we know our times tables, we know 4 times 3 gives me 12. So doing the opposite operation, dividing, 12 dividing by 4 then gives me 3 because I have 3 in each group here. So let's actually look at what we got here. So I have that dividing each of these groups by 4 gives me 10 and 3. So the total when I do 52 divided by 4, well, that gives me 13 here. So that's kind of interesting because let's look at what we actually did. To find this out, we went, all right, 52, we split that up into, 40 plus 12 divided by 4. And then, we took this 40 and then divided it by 4. We went 40 divided by 4. And we added that to my, let's do it in another color, my 12 divided by 4. Now, does this look familiar to you? Hopefully this is ringing some bells, but this number outside, both divided by 40, we did 40 divided by that number, and 12 divided by that number. That kind of looks like the distributive law that we talked about in the previous topics, especially multiplication, right? Now, this works in the exact same way. So we can use this as a mental strategy to think about dividing some larger numbers, some numbers larger than what we're used to from our times tables. So if we have a look at one more example, let's do, for example, 93 divided by 3. Okay, well, let's break up 90 into, let's make it 30 plus 30 plus 30 plus 3 and divide all of that by 3. Hopefully, you can see how I've dissected this number, but I can break 93 into 30 plus 30 plus 30. That gives me 90, and then another 3 on top of that. And then I can go ahead and divide each of these separately. So I have 30 divided by 3, plus my second 30 divided by 3, plus my third 30 divided by 3, plus 3 divided by 3. So I get, for each of these here, they're the exact same thing. So 30 can be split into 3 equal groups of 10 here. So I get 10 plus 10 plus 10. And when I divide 3 by 3, well, how many times does 3 go into itself? Well, it only goes into itself one time. So anytime we're dividing a number by the same number, we're going to get 1, right? So I get 10 plus 10 plus 10 plus 1. And altogether, my answer, when I add those, I get 31. And you can even check that into, you can even put that into a calculator if you like on your phone or whatever, and you'll see that this same pattern happens anytime we want to divide. So we can break up our dividend, this number here, into smaller numbers that 3 goes into, that we know that 3 goes into. So we know it's going to go into 30 because we know our times tables. We know that 10 times 3 gives me 30. So 30 divided by 3 is going to give me 10. And 3 will always go into itself. Any number will always go into itself just one time. So We've covered, in essence, the distributive law here when working through these questions. And this is a mental strategy for dividing these bigger numbers. And I don't expect you to draw this every single time. That's going to take way too long. But by showing you this pattern, hopefully, now you can see that we can apply our distributive law in whatever way we like to work with these questions. Now, in the next video, we're going to talk about using the short division algorithm, and then we'll finish off with division. We'll have a couple more topics, little subtopics to round off our topic of computing positive integers. But thank you so much for joining me today, and I'll see you in the next video.